Okay, so we're getting into factoring now. We just took a test on distributing and multiplying polynomials. Obviously, I'm not here today, so today you're going to start the section on factoring, which is kind of the opposite of distributing. So if we think about distributing, just take this example. Take a minute to look at that and think about the actual process of distributing. So we're taking this 4 and we're distributing it to the whole term. So we're multiplying by the 2x and multiplying by the 1. And we get 8x minus 4. So factoring is just the opposite of distributing. We're going to take that greatest common factor, which is 4, out of this polynomial. Okay? And the first thing we need to start to look at is finding the greatest common factor of something. So on the packet I gave you, on the first page, number 1 is done for you. You're finding the greatest common factor of 12 and 16. So 12 can be broken down into, you guys have done this before in lower grades. 12 can be broken down to 3 times 4. And then 4 can be broken down to 2 times 2. Now 3 and 2 and 2 are all primes. Okay, so we're done with 12. Then you go to 16. That can be broken down to 4 and 4. 4 can be broken down to 2 times 2. Remember, this is multiplying. Okay, that's going to be important later. And then you just pick out the ones they have in common. So they each have a 2 in common, and they each have another 2 in common. So the greatest common factor, 2 times 2, is 4. So the GCF is 4. Okay. So you have 4 more examples there that I want you to go through, number 2, 3, 4, and 5. And that's just simply warming up, getting used to finding the greatest common factor. So then if you flip to the second page, we're going to find the greatest common factor of the terms in each polynomial. So we're going to take a look at those polynomials that we were working on. The first one is 3x to the 4th. Well, I won't do that one. That one's done for you. I'll do the next one, number 7. 4x to the 5th minus 24x cubed plus 8x. So the first thing we want to do is use our factor trees to find the greatest common factor of these numbers. Okay? So I have all the terms written out for you underneath. The 4x to the 5th, really that's 2 times 2 times 5 x's. That's all x to the 5th is. And then 24x cubed. 24, if you're having trouble, just use your factor trees. 24 can be broken down into 6 and 4, and then 2 and 3, and then 2 and 2. So you'll use these prime numbers. So 24 is 2 times 2 times 2 times 3, and then 3 x's. Okay, and do this while I'm doing it on the board. And then the last one is 8x. Okay, 8's 4 and 2, 2 and 2. So it's 3 2's, and then an x. So at first we were just finding the greatest common factor of numbers. Now we have terms with variables in it. So it's the same thing, nothing changes. You just circle the like terms. So they have a 2 in common. All 3 have a 2 in common. All 3 have another 2 in common. And then all 3 have one x in common. Okay. These two have a 2 in common, but the third term doesn't. These two have an x in common, but the third term doesn't. Okay. So all 3 of them have to be have that term. So then the greatest common factor is, I guess you have that line to write it down on. The GCF is 2 times 2 times x, which is 4x. Okay, so now you have 3 more of those to practice. And then if you go to the next page, the last page, it takes another step further. So we know how to find the greatest common factor. We know how to find the greatest common factor of a polynomial. And now we need to know why that's important. So we're going to take a look at number 12. That one's not too bad. So you have 11 done for you. And here's 12. It's 9x minus 6. So you have to find the greatest common factor of these terms. 9x and 6. So we write out the factors like we did before. 9 is 3 and 3. So it's 3 times 3 times x. 6 is 3 and 2. So it's 3 times 2 times x. They each have a 3 in common. And they each have an x in common. So the greatest common factor is 3x, 3 times x. And then to write that in factored form, all you do is bring the GCF outside and then put everything else in parentheses. So this would be a pretty good note to take right here for doing number 13 and 14. You take that greatest common factor, you put it outside the parentheses, and then whatever's left, so what's left is right here, goes back inside the parentheses. So the 9x, what's left is a 3 minus, because this is a minus. And then in the second term, what's left is a 2. So you put a 2. Oh, I guess x did. Oh boy, I screwed up. The 6 didn't have an x, so that's not common.